Good morning everyone. Today we are working on ratio controller simulation. This is one of the problems that we'll design in Hysys. So before going into the Hysys and problem, I just want to mention some points about the ratio controllers. So this is kind of the feed-forward controller which manipulates the flow of one stream to maintain the desired flow ratios between two or more streams. Disturbances are measured in the streams and their ratio is maintained at a set point by controlling one of the streams. Now in the last lecture we worked on cascaded split range controller, where you see that we were manipulating two variables, but in today's problems we are working on the ratio controller, where we are collecting the process variable parameters from this stream and these streams, and using the ratio controller we are only manipulating one final control element, which is your control valve. So that's what it meant to say, that at a set point by controlling one of the streams. So let's look at the problem. It is saying that cold and the hot water streams are being mixed in the mixer. Cold water is at 23 degrees Celsius and hot water has a temperature of 82 degrees centigrade. Each stream has a flow rate of 192 kg per hour and at a pressure of 350 kilopascal. Consider a 10 kilopascal pressure drop across each valve. So this is my hot water going in, this is my cold water, this is my mixer, and we are recording the flow rate of hot water here and cold water here. The signals are going to the ratio controller, which is manipulating this valve in order to maintain a specific ratio of mass flow of cold water and the hot water. Is saying that develop the data logger strip chart for the ratio controller, cold and hot water streams using flow controller 1. So this is the controller which is of our interest. Use ASME stream as a fluid package, and PV process variable and reference PV reference process variable ranges are 0 to 500 kg per hour. The controller's process gain parameter Kc is 0.01 and the initial time for calculation is 1 minute, which is your integral time. Now we are going into the Hysys and see how we work on this problem, but before that I just want to mention a point. We need to have a valve connected at the exit of the mixer. This is because based on the pressure drop or the opening of that mixer, this controller is going to regulate these ratios of the flow rates. So let's go to the Hysys and develop a steady state process first, and then we will convert that into the dynamic one. So what are my components here? My component is water, and I'm using ASME as a steam fluid package. And this is my water, which is here. So we are in Hysys now. We add up our water as a list, and the fluid package is ASME, and then we go to our simulation environment. So the first step is we need to develop its steady state system. So we must have one mixer, 1, 2, and as I mentioned, we must have a controller here. 3 controllers should be there. So this is my mixer, this is my first valve, this is my second valve, this is my third valve. When we were doing our last lecture on, which was the workbook number 5, if you recall, we were having 2 controllers being manipulated by the controller at the outlet. But in this example, because it's a feed forward controller, the one controller will help to identify the ratios. So let's go here. This my valve is based on my hot water. You double click this and let's give it a name of valve number 1, and I say that hot water inlet, and let's say for the output I give it a name of 1 to the stream. And then we enter our drop in pressure, which is 10 kilopascal. This is given in your statement here. You can close this, and then we go to our second valve, which is, let's say we give it a name of valve number 2, and it is the cooled water inlet. And let's say I give it a name of number 2 stream. The next step is we need to provide the delta P for this. For that, go to the parameters and enter 10 kilopascal as a drop-in pressure. Double click on the mixer, and we can have a stream number 1, and we have stream number 2. They are getting mixed, and let's say the output stream is number 3. And now you can close this and click on this valve. This is my valve number 3, and my inlet is number 3 here, and I would say the mixture of hot and cold water. And then I provide my drop-in pressure, which is 10 kilopascal. So far we are doing the same steps as we were doing in the last lecture when we were working on split range controller. So the next is we need to provide the properties for our streams. So let's go here. Now the hot water is at the temperature of 82 degrees Celsius, and each stream has a flow rate of 190 to 192 kilogram per hour and a pressure of 350 kilopascal. So let's highlight this part here and enter this into our hot water properties. So my temperature is 82 for this hot stream, and 350 kilopascal, and 192 kilogram per hour is a flow rate. And then the composition is it's only one component. You can just click on 1 here and press OK. Now I have defined my stream, and this has been converged. The second is we need to go for the cold water properties, and the cold water is at 23 degrees Celsius, and the properties of flow rate and pressure are the same. So let's enter this one here. We have for cold water inlet, we have the temperature of 23, we have the pressure of 350 kilopascal, and a mass flow is 192. The next step is we need to provide the composition here. It's only water, so hit 1 here, press OK, and now you can see that my system has been converged successfully. In the next step, I need to size my valves. By that I meant to say, let's click on the valve number 1 and go to the rating. By sizing, I meant to say we need to confirm Hysys that the CV value it has calculated, we are okay with that. If you have your own values of the CV for the valve, then you can provide them here. Otherwise, you can accept Hysys values. But Hysys needs to know either you are fine with these or not. So you just need to click on size valve, and now Hysys has confirmed that you are okay with the values. The same step for valve number 2, go to the rating, and this is the value of the CV. You click on size valve, and it has been okay now. And same thing is for valve number 3. This is the value of my CV. If you have your own values for the CV, you can provide those too, and then we can close them. In the next step, we need to bring in our controller here. For that one, in the object palette, just go to the dynamics, and this is my ratio controller. Bring that into our simulation environment. Now I can close this window, and I can make a little bit space here. So this is my ratio controller here. You will double click on this, and here you will see that we have the windows for process variable source, and we have the windows for output target object. If you go to your question statement, it was saying that you need to provide the ratio controller using the flow controller number 1 for the hot stream. That's what was our objective. So this means to say my flow process variable will be from this stream here. So I can click on this, select here, and for the hot water inlet here I have stream number 1, and then you need to choose the mass flow. And hit select here. How we are going to manipulate this flow? It is by using this valve number 1. So go on select OP, which is the output target object, and select your valve number 1, click on actuator desired position and click on select here. Now let me explain you what is happening here. So your controller is going to take the signal from stream number 1. It will provide that signal to the ratio controller, and the ratio controller will decide how much valve it should close or open in order to have a specific ratio of the streams. Now because I'm talking about the ratio, this means other than this process variable, I must have some other stream on the basis of which I can refer to this stream, and that what is called as a reference PV in a ratio controller. So right now we have the controlled PV process variable, which is stream number 1, and just click here and enter your reference stream here. As you can see, it has given me a space where I can enter my reference stream. So this flow rate is being measured with reference to this stream, and that's what we need to add here. Click on select PV, and now this stream has number 2 here, and again we need to work on mass flow. And click on select. We have selected reference for our valve number 1, which is the stream number 2 here. You can also select it and you can flip it to make it more reasonable, understandable. So what is happening here again? It is calculating the flow from this stream number 2, calculating the flow from stream number 1, and ratio controller, based on the required set point of the ratio, it will adjust this valve. So that's what is the whole purpose of ratio controller. Now let's go to our next step, which is we need to provide the range for PV, and for that one go to the parameter and go to your range here and look at our statement here. So the PV and the reference PV are ranging between 0 to 500. So the PV for stream number 1 is 0 to 500, and for this second stream it is again from 0 to 500. Once you have specified these ranges, go to the configuration, and here you need to provide the tuning parameters, which are also given in your workbook here. So these are the tuning parameters. Let's take blue color. So the controller K value is 0.01, and initial time for calculation, which is the integral time, is 1 minute. So this KC is 0.01 and the TI is the 1 minute. The next step is we need to develop a strip chart. Go to the strip chart and click on SP and click on create the strip chart. Now this OP is your output. We don't want to see this in our strip chart. You can unselect this. So this is our strip chart, and you can move it at -100. You can close this window and click on the faceplate. That's what we will use when we run our dynamic simulation. So now we are ready to enter into our dynamic simulation. Click on the dynamics here and click on the dynamics mode. Now the dynamics assistant has identified that there are some problems that need our attention. Click on yes, and these are all the issues that are available in our system. So there are two ways you can fix them. Either you can fix them on your own, or you can ask Hysys to do so. I'm going to ask Hysys to resolve these problems if it can. So let's click on the make changes. This is the change which is not done by Hysys. Double click this, and this happens because our mixer is not modeled in a dynamic way. So what you can do, just click on the OK and ask Hysys to make the changes. Now as you can see that all changes were made, there are no remaining problems. Now we can close this window and go to the dynamics mode again. Are you sure you want to switch to the dynamics? Yes. And now we are in dynamic mode. Before running the simulation, let's bring this parameter window here, and this from this palette I can make it automatic, or I can make it from here as well. It's the same thing. Now you must understand what is going to happen here. So with this system here, Hysys is calculating the flow rate of my stream number 1, which is 192 kilogram per hour, and from stream number 2 it is calculating the flow rate of 192 kilogram per hour, and their ratio basically is 1 at the moment, which is being fed into the controller, and based on that it would regulate the valve. So this is the whole phenomena here. And here you can see that I'm not able to change the values of my process variable either for stream number 1, which is this, or stream number 2, which is reference process variable. If you want to change them, you need to go back to the properties of the hot water and the cold water, and that's where you can modify your mass flow rates for these streams. However, what we can change the ratio of these two. Let's say I make it 0.7, and now I start my simulation. So you go to your dynamics mode and run your simulation. So as you can see that my simulation is running, but one of my scale is not within the vertical axis, as the value is 2.6, whereas it is the maximum is 200. What you can do, right click this, and you can click on auto scale all axis. Now I have both of these scales within my y-axis. So at this time, what is happening, my process variable, which is my stream number 1 flow rate, is 144.9 kilogram per hour, whereas my flow rate in stream number 2, which is my reference process variable, is 206.993 kilogram per hour on this stream. And the ratio of these two, which is the ratio of the process variable divided by the ratio of the reference process variable, is 0.7. And this is what Hysys is adjusting these for me, and we can see how the ratio controller is behaving. Let's change them to 0.5 and see. As you can see that it has changed it ratio again, and now I have the flow of my PV is 108.7, which can also be seen here, and the flow of my reference is 217. If I make it 1, I will get a straight line, because in that case the ratio will be 1 here. As you can see that both of them have combined up to the value of 192.00 now. So they are the same. That is why I have the ratio of 1. If I increase this ratio, that by that I meant to say my PV value is higher than reference PV, then you can see that let's bring it to auto scale again. You can see that my reference process variable value is 169.5, whereas for my PV the value is 254. So you can try them on different ratios and see how it is manipulating your variables here. I will do a couple of modes just to show you how our controller is behaving at this time. So let's say I make it 0.9, and you can see that the change in your dynamic mode here. As you can see how abrupt this was changed, because I drop the ratio significantly up to 0.9 here. Or if I want to increase it, let's say 2, it should open the valve to adjust these flow rates. So I hope this helps. If you have any questions, you are welcome to email me.